we're going to jump and we're going to look at the quiz. So basically, there are three ways that we're going to deal with input in Unreal. And you're going to be shown how to get input via blueprint event nodes. That's one of the things we're going to go over in class. There's two other systems. There's the input bindings and the enhanced input system. I'm just going to talk about them. Where do you set up in the input bindings? Well, I'm going to show you right now. And it's under project settings. Here we go. So it's under engine input. There we go. And the big thing I want to be, these are settings saved in default input.ini, which is currently writable. This is the old input system that Unreal has. And they use bindings based on action mappings and axis mapping. So action mappings are basically buttons, and axes are basically anything that's a float or a vector too. They are now depreciated. That's the important thing, is that they are moving away from this system for what they call the enhanced input system. And basically they've got action mapping down here, new action mapping, let's just call this something. We open it up and it's like, hey, what's the key? We'll say keyboard, tab. And so now we have a button mapping that when we hit tab, we know when the tab key has been pressed and when it's been released. All right. Axis mappings, I'm going to make just one for the sake of mapping. I'm going to do some axis. We'll open up, and and it could be something like the keyboard. It could be, again, let's go to the gamepad. And left thumbstick x-axis. Or it could be the left thumbstick 2D axis. So this is going to return back vector 2 with the x and y. All right. This system is old. It's archaic. It's being replaced. You need to know this because there'll be things that there'll be tutorials out there that are going to refer to this. You need to know what's going on here so that you can apply it to the action to the new enhanced input action system. So I'm actually going to delete all of these because I don't want any of these. All right. The other system, and this would be under third person, there's a folder called input. And so essentially there are two parts of this new system. There is the data, there's mappings, so input mapping context, and then there is actions. Jump, look, move. I'm actually going to go in, I'm going to add one, and you'll go down to input. Get that out of the way. So I'm going to go down to input and add a new input action. In this case, I'm going to do and start with IA because this is input action. So start with that convention, IA, and this I'm going to use fire. So this is fire. I'm shooting a bullet type stuff. I definitely want to go in, and there's all different things in here. One of the things that you can do is there are I think 2 triggers that I want to set, and this is pressed and released. So for a button, I want to make sure I get pressed and released. So I can do things, I can write code based on that information. Not every button needs that, but there again, and there's also things that you can also. What is the description? What is the value type? We can look at, is it a 1D float? Triggers. 2D axis, vector 2, thumbsticks. Vector 3, the axis 3D, the full vector. That's going to be like a joystick, not a joystick. The position of your VR controller in some source in your local that local space. That's kind of why this is here. Mostly you're going to use these two for the most part. You'll be like, oh, I'm going to map this to. So I'm going to keep this a boolean. I'm going to save this. I can close this now, and now I can go back down to the mapping. Now I could create another mapping, and the first person shooter, what they do is when you pick up the weapon, it adds another mapping. So one of the things that this system does allows you to add and remove mappings in a connection based on context. So if you have a weapon, it adds the fire button to your list of commands. For my purpose, I want this in, again, we look right here. Here is the jump, move, look. I'm actually going to add, I'm going to add the fire right into this. And I'm going to select the asset. And I'm going to ask, again, look is, the mouse 2D. It's got the move keys here. Jump is here. So with fire, I'm going to go and I'm going to add, I'm going to click, and you can click this right here and then click the key that you want. And so it's right now looking for, hey, what's the next input? My left mouse button ends up being that input, and that's what I'm going to put here. I can add more. Again, I can add another mapping. So here, actually, I'm actually going to go to the gamepad, and I'm going to. So Unreal. So remember, triangle, square, X, circle versus A, B, X, Y. They are abstracted in, where Unity goes north, south, they go face button, bottom, right, left, top. And I'm just going to go face button, bottom. So on the Xbox controller, that ends up being A. And then on the PlayStation controller, that is the X. I don't have a switch, so I can't tell you off the top of my head what that's on the bottom. But anyways. B's on the bottom. Yeah, okay, there we go. Thank you. So now I have a fire key. All right, and I'm going to close my mapping because I don't need it open. And I'm going to go and I'm going to show you. So how this ends up working, so here is so we talked about pawns. Where's my, I'm going to just drag one into the scene just for the sake of having one in. So here is what would be my pawn. I'm going to delete this in one moment, but I'm going to open up its class. And you can see up here, one of the things is that it adds input mapping. So on begin play, it goes and gets the controller, gets the enhanced input system for the controller, and adds the default mapping. And you'll see this regularly, like this is done on both in here Blueprint in C++. So, but here is camera input, the look, movement input, the move piece, jump, and then I'm going to basically go right in here, and I'm going to do IA fire. You can see that here's the enhanced action event. So I can wrap my node, and I can see that when it's triggered, and there's more I can do when it started, ongoing, canceled, completed. So this is occurred after one or processing tick. Has begun. Trigger may also occur this frame, but this event will always be fired first. So it'll do started first. Ongoing when the button's down, and canceled when they've let go. I'm going to use started for just the sake of argument, and I'm going to do print, and I'm just going to go right in here. I'm going to say boom. And I'm not going to do anything special here, but I'm just showing you that I've added a new action. I've added to the mapping. I can now compile this. I can now go into my, let me grab this, put it here. I'm going to remove this because I need to spawn in with my object. And if I hit left mouse button, you can see, I'm now printing boom into the screen. And I could be doing a lot more, but I'm just showing you, hey, here is how the input mapping works. All right, so I've shown you the old buying system. I've shown you the input mapping system. There is, if we go jump into, let's say I want to do something with the Q key, and I'm not playing with the input mapping system. I can actually do keyboard, and here is keyboard events Q. And this is press and release. And I'm just going to do a print string here. And I'm going to do Q key pressed. Can you follow along and not, please? Thank you. And I'm going to compile and go back, and I will press play. I'll hit Q. You can see the Q key pressed. You can see mouse button, boom, Q key pressed. And so the input is working. All right. This is, hey, am I getting input? Yes, I am. So these are the two ways, again, these are the two ways that you will be working in your labs going forward. The problem with this is that you are hard coding your controls. In the enhanced input system, there's a way to, if you are building on a bigger application, you can rebind your keys. That's available to you. Again, this is to the action and not to the binding. So that's the key piece here. So I want to just point that out. Ultimately, you're binding things to actions, and then later on, your input is attaching things that when I press this action happens. So there's a separation of those two. So again, where do you set up input bindings? It's in project settings. What does indicate binding system? It's all the getting rid of it. The enhanced system has two parts. What are they? Input actions, the inactions, and the mappings. And then what's something that the enhanced input system allows that the input system does not? It's basically allowing to add and remove mappings on the fly. So you can have input contextual based on what's going on. Okay, let's go through these PowerPoint slides quickly. Let me just there's one. So I'm going to briefly, so that there are 3 exercises that you'll do. There we go. So basically, you're gonna switch between different. So we're gonna put three of those characters into the scene, and you're gonna switch between them clicking 1, 2, and 3, and we'll show how you do that. So that's your first exercise. Exercise 2. Oh, and you're gonna make a timer. So we'll go over that in a moment. And then you're gonna create an actor that's gonna move across. So you're gonna create an actor, and that actor is gonna have an array of path points. and we've got a whole slew of different variables. There are going to be methods that you're going to want to create, and we'll talk about them in a second. The big one is that when you are calculating like where the direction, like I'm here, I want to move there. It's wherever that point, the location of the other point minus where you are. So it's the B. So A is where you are, B is where you want to go. The math is the vector math is B minus A is the calculation for the direction you want to move. We'll talk a little bit more about that in a second. Now, let's go through the slides. All right, so common classes. So basically there's the object class, and then basically you either are creating an actor component, which is basically something that you're adding to as a component to an actor, or you're creating an actor itself. And again, we saw controller, player controller, AI controller, game mode, pawn, character, vehicle. We can set our own, when we set up the game mode, we can set up what those classes are. So this week we're actually going to set I think a HUD class, and we're going to set up a pawn class. Well, actually, I think we'll set. I think we're setting. We're definitely doing the HUD class for the timer. But anyways, moving on. We've looked at assigning game modes, game state. Not really worried about player controller. Again, two subclasses. Again, the big one is you will on a regular is get the player controller. And then you will say in here, basically, so the idea is that the controller possesses a pawn. So here, enter get player controller 0, so the first player, that's the target, and the pawn. What is the object that they are going to, and this is again being done in the blueprint. I think this is done in the level blueprint. So one of the things that we'll do this possessions. This is basically this is where your first piece of the lab is going to be. It's like right here. Key, possess, get the player controller. What are we possessing? In fact, let's do that right now. So I'm actually going to go drop. So here's my spawn point. Let's put. So what they're asking is to take. This is the pawn that we're using. So they're saying drop this into the world. For sake of argument, so that we know that this is. So this is the standard model. I'm actually going to go into my content draw. I'm actually going to go to starter content. Go to materials, and I'm going to give. So this one is gold. So we know that this, and so what again, I'm going to click on them, and I'm going to rename them player number 1. And with that selected, I can actually now go back into my level blueprint. And I'm going to use keyboard, the 1 key. So when that's pressed, I'm going to use possess. Actually, what I want is get player controller. Get controller. There we go. I don't want to use. That's not what I want. But I do want the player one reference. Um, there we go. Get player controller. There we go. So here we can then, and I'm gonna move these this way, and then we can do possess, and that is going to do the pawn. Now I'm gonna copy and paste this because I actually want a event begin play. What I actually want to do is create a variable, and this is going to be a type of actor, and it's going to be an object reference. And this is going to be, I'm going to call this spawn player. So on begin play, I'm going to get the player controller. There we go, get control pawn. And I'm basically going to drag this out. I'm going to set this. So from the player controller, I'm going to use the function get control player, and I'm going to get the spawn player. So when I spawn in, now I know what the character is, because it's not gonna be in the scene. So it's not like I can drag it in here in this regards. I'm actually going to go in to do keyboard. I'll use the 4 key. I'm gonna copy these. And now I'm just gonna get that, and I'm gonna plug that in here. We'll plug that in here. I'm using an actor, but I actually need to do a pawn. Need to go to the pawn reference. Change variable type, and it's gonna. There we go. There we go. So it again, what this actor is a pawn. That's why I was able to apply it to the pawn reference. So, so look, everything's good here. I will compile. I'll jump into my map. I'll press play, and you can see here I am. I'll press the 1 key, and you can see now I've jumped to my gold version. I'll hit 4, and I've jumped back to my original. Well, what was the question? Turn to me.
You can move the camera over to the one you just selected.
It's the camera. So there are 2 cameras in the scene. There's one on the first pawn, and there's one on the other pawn because they're connected. So when I pressed 4, sorry, when I hit 1, I am now on this pawn, and I'm using the camera that's connected to it. When I go to the other one, I am now using the other camera.
But you know, like your camera moves really fast, like it's the other one.
What do you mean the camera's moving fast? No, I'm not. The camera's not moving. I'm switching actual cameras. It's a cut. Camera 1, camera 4, camera 1, camera 4. So, so that's your first section. All right. So I am going to drag out. Go back to content. Third person. Let's see. There's number 2. Put. And then I'm going to rename this player number 2. And now let's go to the content draw. And this one will be Rusty. And then I'm just going to, here's player number 3. I'm going to pull them. Over here. And go to the content draw. I'll make you Mossy. There we go. So we've got all of these in play now. Why am I doing this type of setup? What I'm going to do next is we're going to create a new blueprint class. So go to our content. I'm going to make a new folder. And I'll just call this Lab 3. Just so I can keep things out of the way. And I'm going to, what did I call? So we're going to get a new blueprint class. It is going to be an actor. And this is going to be BP, I'm just calling it Path Runner. I'm not sure. And that's kind of what it is. And I'm going to just add basically a cube. Yeah, I'm going to add a cube. And I will make this just a little pillar just for the sake of argument right now. And I'm going to move it up. Nope, I wanted 50. There we go. So basically, I want the default. So the bottom is the default scene root. So it's standing on top of this default scene root. Compile. And so one of the things I'm going to do in here is I'm going to have a path array. And it is going to be of type of actor. We want object references. We want this instanceable. And I'm going to put this in the path runner category. And this will help you separate your variables out. So start using categories as you go through. Notice that I have no collision on this. I'm not setting up any collision on this. In fact, I'm actually going to go to the cube and make sure its collision is set to no collision. So basically making sure this can move as it needs to be. So I'm going to save that. I'm going to go back to my map. I can now drag the path runner into the scene. And here at the path runner, I can then, I'm going to go back. I made a mistake. When I set this up, the path array, I needed to select this right here and set this to an array. Now you can do this. There's sets in their maps. There are other ways to do things. I'll let you look at those and on your own. But basically, single is single variable. Array is multiple variables. So I need to set that to be an array. Compile when I go back. Now it is array elements. And I know I'm going to need 3. And again, I need to click on my path runner. I'm going to lock it so I can then go back to, so I can assign these in the editor. And My apologies. I parented the player to another object, and I was having a problem getting it unparented. So now I can reassign these. There we go. So now this array is now assigned to what's in the scene, and that's one of the things is that you will be assigning. There'll be objects that you will create that are in the scene. So again, things that are in your level that you will assign variables to, and that's going to become a very common practice as you get further along. We will do some of the more of the math, how to handle that in one moment. But let's go back. Let's get back to our slides. Player state. Again, I'm just going through it. We've talked about pawns. Character again. Have I? Yeah, we've already gone over these. Vehicle class, HUD. All right. So head is what you use to create a heads-up display. The HUD class consists. There's the HUD, and there are widgets which attach to the HUD. So there's two things to worry about. Like if you are making a module like that for a particular piece of the HUD, it's going to be a widget. Talk about game instance, game session. Yeah. Let's move on to the next one. So advanced blueprint concepts. Again, I just showed you how to create an array. And you can create an array of any type of variable, any type of class. So floats, vectors, integers. I could have made an array of vectors, but that means I have got to go in and set each of those vectors myself. Whereas what we're going to do is with the pawns, with the actors, we're going to ask for their location, and that's going to give us our vector in space. So that's why I went in that direction. You can get an element. You can ask for the length. You can add to it. You can insert. You can also delete.
Why don't we ask for the length?
Because you want to know how many things are in it.
Okay.
So if you've got an array that you're adding or removing, let's say we've got all our coins. One of the things that we can do is that the game mode would have a collection of the coins. Would it know all the coins are in the game? And as a coin gets collected, it would tell the game mode, I've been collected, and then remove itself from that array. And when that array ultimately becomes 0, now you know that all the coins have been collected. So we can ask the array length. So sets, similar, but it's an unordered list. They're searched based on their value. There's no index. Hooray! Have fun with the set. Maps basically there is a key value basically is what we're talking about. So basically map variable for map. So here is health, life, money, shields. These are the values. It's a map is basically think of it as there is a so in this case they created a string and a integer. So typically you have a string that is a key and then of some sort of value that you're going to hold.
So do RPGs use map systems?
Sorta. They go into more. The RPGs are using. They're showing the next thing here is structures. We're not going to deal into structures per se, but this would be more complex data objects. So an RPG would be using more structures. I'm not going to let you read this because essentially enumerations. The idea behind enumeration is that you let's say here basically they have 3 types of weapons: shock rifle, flat cannon, rocket launcher. And that would be this would be a set of these 3 items. A common enumerator you'll see when teaching is the days of the week, names of the months, and that you have an enumeration that holds what day it is. You have an enumeration that holds settings for an object. Like this object can be in this mode, and that mode. That would be an enumeration. They'll come up later. This is here for your benefit. You can create, you can use. We'll look at enumerations later on. You can switch on. So basically, here's they created that enumeration, and then they can do on begin play. What is the weapon type? What is the weapon type? This is some variable that they're setting, and based on that, they're setting what weapon it is. Apparently, in this case. So we'll move on. Data tables. This is getting further. I'll let you read this. So this is getting even further deeper into the RPG realm. I'll let you read what data tables are. You're not going to, unless you're doing something very specific, you're not going to be using data tables right out of the gate. So, but you should know that you can do data tables. Latent functions. There is delay function. It connects to completed pin only after duration array. Retriggable delay. So that you can there's a layer. So this is it will retrigger after every 2 seconds. So here is how you would a timer. Set timer by event. Set timer by function name. So what is the function you're going to be using? And then here is loading levels. You can open a level. What is the level name? Maps. And we'll not going to too worry about it. You can get we go. So it's looking for an asset name. So we go to the content draw. We go to here's maps. So here's the map. We right click and we can where is it? Copy file path is what I'm going to look at, and we will bring that up. We paste it right here. So here is basically see you working on Unreal, content. Ideally, this would be probably third-person maps, third-person map.umap. You probably would, for loading level, you would basically, I believe, it would be just this. Third-person maps, third-person map. That's what they're looking for. Later on, you could, if you wrote your own function to load levels, then you'd be like, oh, I don't need to. This will append this to the string, and all I have to do is put in the level name. All right, so transform. So when we talk about a transform, we're talking about a location, a rotation, and a scale. That's when this is whether it is in your 3D editor, this is in Unity, in Unreal. This is the transform in a nutshell. It consists of a location, a rotation, and a scale that define where it is, how it's rotated, and how big it is. Typically, scale you will see ones across the board for no scaling. And for a lot of cases, you don't want to scale unless you only want to scale when you absolutely have to. And there's reasons for that. Rotation. 0 across the board, no rotation. And then here we've got our location. And again, they're showing here, right here, these are the where you can click for change the gizmos to move, rotate, or scale. World coordinates. So, wow, okay. 3D space is represented by three axes. The x-axis is considered the forward direction, and the z-axis is considered the up direction. This is what you are most commonly, again, latitude, longitude, height. Those of you who are working in Unity, just remember y is up over there, and I have to point that out because Unity has to be silly in that direction. All right. So when we talk about the world, like basically these axes don't move; they don't rotate. Like this axis is always going down the x-axis, is always going the y-axis, is always going up the z-axis. Now, when we talk about now you can have another set of axes that are local to your object. In fact, let me go back to Unreal. So right now I am in world, and I can switch. Let me click on this object. Let me see. There we go. So right now I'm looking. This object has no rotation. It's looking down. This is the forward direction down the x-axis. I'm going to turn this. You can click to local, and I can turn this, and you can now see that the x-axis is pointing that way. It's pointing down where it's located because that's the forward direction. I flip this back. You can see that. Bring it over here. It's now flipped in that direction. I'm going to go rotate it a little bit more. Rotate this way. Go back. So you can see that the world axis still pointing down that way. I'm pointing in this direction. And you can see how it's flipping between this is the local, this is the forward axis, and this is its global axis. So that's one of the things you're gonna deal with is working in the global space versus the local space, going in between the two. Know when you need to work in the local space where you as opposed to working in the global space. Like for our purposes right now, we're going to move this in the global space. Not this one. This object is going to be our pathfinder. We're going to move them in the global space. But we will have them rotated and we'll move them in the forward based on, again, there'll be a forward direction that we'll assign, but that will be basically essentially based on how this is rotated. All right, let's go back. Again, get actor location, set actor location, set actor world offset. You wouldn't necessarily be doing set actor world set. You'd be setting more actor location. Again, these are setting them in the global space. Now, we had a component, or we wanted to, there is a way to set things in a local space as well. So set relative location is so Unreal uses the word relative when it means local. Why? Because it's epic. Go figure. And then it says set world location. So that again, you can go very specific. You can get the relative location. You can get its local location. Points and vectors. A vector represented, a point in 3D space is three vectors, x, y, and z. So every actor has a location vector that's a vector 3. So here, again, we can also represent movement and direction. So here's the chair, 300 centimeters in this direction, and this is assumed down the x-axis is 300 centimeters. That's 0, 0, 0. This is going to be located at 300, 0, 0, 0. Vector addition. So basically here they got a vector of 509, 402. When you add vectors together, you add the x component, the y components, and then the z components together. So 5 plus 4, 0 plus 0, 9 plus 2 gives us 9, 0, 11. Subtraction is basically it's a. So this is v1 minus v1 minus v2. Basically, you've got 12, 0, 14 minus 4, 0, 8. 12 minus 4, 0 minus 0, 14 minus 8, 8, 0, 6. Length of a vector. So basically, it is the Pythagorean theorem. It's a squared plus b squared plus c squared square root of. And that's going to give you a vector length. Normalizing vector. So when we have a vector, we have both a direction and a distance. So to make that make sense for us, we normalize it down to a scale of 1. So if I've got a vector, so let me use a 2D vector for a moment. If I've got a vector 1, 1, and I want to normalize that, that's a scale of about, that's basically, so it's 1 square plus 1 square, so it's square root of 2. Square root of 2 is basically about 1.4. If I wanted to normalize the 1, 1 vector, it actually would come down, the vector actually would be like 0.7, 0.7 is approximately what that normalized vector would be. But that would give me a vector that's scaled to a length of 1. Why is that important? Because if I wanted to move in the direction, if I didn't normalize my vector, I would be getting an extra bonus to my movement that I wouldn't want. So there's games out there where you move faster on a diagonal. That's why. They're not normalizing the vector. With the normalized vector, essentially, I am going to move 50 units in any way around the circle. Scalar vector multiplication. Basically, we can take a number and multiply that by a vector. So again, we take our movement direction, we normalize it, and then we can multiply it by how fast we're moving, and that will give us how much the distance we've actually moved. So a good example here is this is our direction, and this would be the scale, how fast we're moving. Dot product. This is use to verify the relationship between two vectors, whether they're perpendicular or parallel. If they're parallel, they're 1. If they're perpendicular, it's 0. Hey, it's cool to know that there's a dot product. You'll use this later on for other things. Get the actor forward vector. Again, we can essentially, again, here input axis move forward. Again, and there is add movement input. And here is get the actor forward vector. So itself is basically its actor. So again, let's go back into our scene. So this is actually my forward vector based on how it's rotated right now. Click that. There we go. So I'm rotated 30 degrees. This red arrow is my forward vector. Let's rotate them in a different direction. So I'm rotated 100 to negative 100. Here is my forward vector. And so that's what we're asking is basically ultimately like when we use that, as we're asking the object, what is our forward vector? So far so good. Again, there's a lot of math in here this week. All right, let's go back to the path runner. So we know we need a path array. The next thing that we need for a variable is we need to know the move speed. And this is going to be a float. And we need to flip this back to a single value. The other thing we need to know is oh, uh, we need to know when we are within range. Basically, when we're moving. So here's the thing about when you're dealing with moving things with floats and whatnot. The math underneath, the numbers underneath, is really messy. And so to simplify this, we're going to say if we're within this range of the path node, that's good enough. We're gonna say that we've hit our target, and we'll move on to our next thing. Um, I am going to add one more variable, and it's going to be our move direction, and this is going to be a vector. I'm gonna add one more variable. I'm gonna do path index, and this is going to be ultimately an integer. If I can find integer, there we go, integer. All right, I'm gonna compile. All right, so path integer I'm gonna keep as 0 as 1. Move direction we will assign in code. Within range, I'm just gonna point 0.5 is gonna be my, and I'm gonna do a move speed of 100. This will probably crank up. I will make this instance editable. Same with this. These are the two that I want to be able to tinker in the editor itself. Move direction, path index, I shouldn't be tinkering that in the editor. There is going to be one more variable that I'll add, and it's going to be has dynamic has dynamic and it's going to be a boolean. And I'm just going to compile, and just for the sake of it, I'm going to turn this on. No, I'll leave this off for right now. All right, so let's take a look at our event graph. Actually, we need to write some functions first. So the next, this is going to be set move direction. So ultimately, we're going to set this. All right. What we need to do is, so that's not what I want. So I'm going to reference to myself. I need the reference of the path array. And this is going to be get, and it's going to be get a copy. So, and basically for our purposes, we want to plug in the path index in here. So here is where we want to go, where we are at. So pull this back. So the next thing is get world location. Get world. Sorry, get actor location. Actually, delete these. We don't need to. I delete too much. Hold on. I really just want the actor location. I mean, same thing. World location of the cube versus it's just, it's same thing, but I really want to just use the same node in this case. Um, Consistency. So the next thing I want to do is going to be a subtraction. So again, where I am minus where I'm going, and I want to normalize. And I'll plug that in here. And boom. Here we go. I have figured out basically here is my set move direction. In fact, we can actually we'll compile, and we will go back to the event graph. One of the big things we'll do with begin play is we'll set the move direction. No, not that. Sorry. Here is set move. Here we go. So essentially, I've made a new node. We don't need begin overlap. We will actually use tick this time. In fact, what we'll do to make our lives easier, I'm going to make a function called move object. And one of the things I'm going to do with move object, again, we go back to the event graph. You can see there's a delta seconds. We're going to go back to move object, and we're actually going to add an input, which is going to be a float. Let's call it delta seconds. So we go back to our event graph. I'm going to wire in like that, but I'm also going to wire in like that as well. So I'm going to plug that in. Why am I doing this right here? Just so that I can isolate all the work here. I don't need set move direction. So move object. So we now know we have a movement speed. We have a move direction. And so this is literally what's going to happen here is I'm going to multiply, and I can add another pin, add a pin. So this is delta seconds times delta move speed is how much I've actually moved. So if I'm moving 100 units and the delta second is 0.1, I'm going to move 10 units. Now that's very simple math. It's not always that simple. But here we now have our move speed. We can now multiply by the vector, and we'll get a new. This is now so we know how much we moved. Multiply the direction. Now we know the change of our location. Again, we're just going to go get a reference to self just for get actor. Get the actor location, and then we can set actor. So basically, these two are going to get added together. Go from this one. And this will plug into the new location. Bring this down. Let's see. And I connect these across like this. Yeah, what's up? I'm moving the path runner. This is the third piece. So basically, I'm basically moving the object. And if I compile, we'll go back to my scene. You can see that this object is moving towards that object.
Wait, will it still do it if you just run away?
No, no, and it's going to go through it because right now all we're doing right now is just moving the object. So basically, let's go back to our path runner. Wherever we set this direction, we ultimately wherever we set this direction is where this object is going to move. Let me see. We'll come back. Okay. So the next what we're going to do is we're going to create another function, and we're going to ask is close to target. So what is our target? Well, that is essentially our path array. Yeah, it's our path array at so this is our target. So again, we're asking the path array, and we're going to get actor location. We are basically again ourself. I'll plug that in there. Again, don't know why. And then this is again a subtraction. So now we have our vector. We can now ask the length of it. Get vector length. And it's a value. And we can ask if this is less than, and then this is where our within range variable comes into play. And this we can then wire up to an if statement, or the branch as they say. So we'll wire this in. If we are I'm actually going to go to the is close to target. I'm actually using output in this case. And it's going to be is within range. This will be a Boolean. I'm actually not going to use the branch. I'm actually just basically going to just ask So basically, this function basically returns back with whether it calculates the information, turns back with if it's within range. Why am I doing it this way? Is so that in my event graph, next thing is I can ask is close to target, and here I would actually do my if statement. So here's the condition. And basically, if it's not within range, then I don't need to do anything. Off the races I go. But if it is, what I need to do is then I need to set next target. All right. So I'm going to play with the path index. And there is an increment operator. I could have gone and been like plus and add 1 to it. What's nice about the increment operator, I want to, is that I can just plug this in right away. It's going to add 1 to the value and sets it right away. The first thing I need to do though, if I need to check, so I need the path array, and I need its length. And so the question is, no, I need greater than or equal to. So if the path index is greater than or equal to the length of this, if that's true, again, this is going to be the if statement. If this is true, path index set, I need to set the path index to 0. What means, so basically, when we count in an array, we count from 0 order. So it's going to go from 0 to 1 to 2. And then when we hit 3, we're going to be at the length of it. Means it's an object that we won't have. So we need to set that back to 0 to go back to the order of the beginning of the array. This is the first half. We added 1 to the path index. We asked if it's greater than or equal to the length. And greater than or equal to, if something weird's happened and this value goes above, this will catch that and put it back to 0. Again, here is the if statement. So I'm going to compile, go back to my event graph. I can set use the set next target. And because I've set a new target, I'm going to take set move direction, and I'm going to set, again, I've got a new object. I'm going to set its move direction as well. I'll go back to my variables, and my move speed, I'm going to crank this up to 250, 300. Back, I'll go 3 times faster. Compile, we'll come back to our third-person map, and we'll go, see that off it goes, and it missed. What the heck happened? Why did it save everything? Why did it not? Okay. Went through it. That's interesting. Okay, so I need to figure out what's going on. I need to is close to target. Is close to target. And I'm going to print out the string to the and I may need to be within range. May need to be. Oh. I know what I did wrong. I know exactly what I did wrong. It is the within range is not correct. So within range, remember what I said it. We go back to the variable itself. within range. I set it to 0.05.
Oh,
That is
small.
really, really small. Um, this probably should have been 50.
Yeah.
So let's go back. So it was never going to hit that 0.05. So there we go. We go, and in this case, you can see it hit it and it went off. It's now going to this one,
It's like, oh, oh,
and it hit that one, and now it's off to this one. Move this over here. I can run into it. Now that's cool.
wait, what did we start running to the side?
It's gonna go that one, and then uh oh, it's not following me anymore. So the issue here, this is why we add it has dynamic facing. This goes back to our event graph. The first thing, basically, we'll get that if pass it through here. If it's so, this will always happen if it's false, and then we just need to get a set move direction, and this needs to be plugged in like that. So this will so only when this is true, this needs to be updated. So now, and I'm actually going to go back to the variable now. I'm going to turn this on. We'll go back to the third person map. We'll press play. And now, by virtue of viewing the first lab, I can run, the path point is literally running away from it. Gameplay ideas?
monster chasing you?
Possibly.
Wait, hold on. How about the closer it gets to you, the slower it is, but the farther away it is, the faster it gets?
Um, we can worry about that another time.
Okay. Hold on. Wait, can you put in multiple?
What was that?
Multiple ones.
Multiple of these path runners?
Yeah.
Yeah, it is basically set up to run on the path that you set up based on the path points. So it runs. Where's the path runner? This performs based on what you put in the array, the path array. All right, let's go back to. So I've shown you how to do the first two pieces. Again, the path runner, you have to use functions to do it correctly. You need those nodes as functions to make your life easier, ultimately. And one of the things that I probably should, again, I've done this, again, I did this here in the, this right here. I probably should have grabbed this. Actually, I'm going to cut these. I'm going to put these in here, move direction. Again, with these functions in place, again, I'm actually going to go into my move move object method, and I'm actually going to pull this back. I'm going to paste these in. So I'm actually going to go here, and then basically I'm basically moving the, rather than having this in the event graph, I moved it into the move object. Clean. It cleans it up a little bit. I'm actually going to grab this and do a free route node. All right, so I can grab these two, pull these up. Oh, I don't need to now that I moved that all up. I was thinking I was trying to clean this up. I'm particular about how Blueprint is supposed to look. So here's basically, again, here is your visual scripting. Don't get me wrong. If we were to write this in C# or C++ code, this would look a lot cleaner. Like this right here would be much cleaner. Direction, south. And this is kind of aesthetics, but you want your blueprint to be able to be easily read. What we don't want is something like there's a website literally called Blueprints from Hell, and they are just these massive mess of nodes. You can do that another time. Please don't surf to it right now. So I'm trying to keep the blueprint relatively clean, so it's easily read. Again, what I'm trying not to do is like cross the streams. That's kind of this is a aesthetically no. Again, I'm not going to get. You do the best you can. And I can pull this. Actually, pull this probably closer. Pull this in. There we go. And this is what you would ultimately screenshot for me for the assignment this week for this method. So I'm going to compile, save everything. All right. I need to look at exercise 2. I'm going to grab this over here. It says create a new folder, BP guide. Basically, we've got that lab 3 folder. So here's this lab 3 folder. This is where the BP. I mean, let's do. We'll just for the sake of argument, we'll put another folder. BP guide. So in this case, we're going to create a new blueprint class. Now, we're not creating an actor. We're actually going to create a HUD, and we actually need to go down and search all classes for the HUD class. Now, a HUD is basically a specific, again, that specific class that the engine uses. And this is going to be BP HUD. Timer. And we're going to open it up, and the first thing is we're going to add a variable. It's going to be an integer. It's going to be time, and it's going to be an integer. And I'm going to put this in category of timer. What's up? What? What do you mean? How long? Like, you compile when you need to. I'm going to compile this right now. I'm going to compile, and I'm just going to give this a value of 10 for right now. And then, again, because I changed the default value, I need to recompile. Um, go to the event graph, and so I'm actually going to get rid of these nodes. We're not going to use them. And there is a draw HUD, and it's event received draw HUD. And in this case, we're going to use a function called draw text. Now, I'm going to be clear to you right now, this is not normally how you would build a HUD piece. This is for this lab right now. And the document, I'm following along with the exercise document. Wes, you have your hand up.
Sorry,
What's your question?
there's something I was thinking I forgot.
All right, we'll come back to. We'll go back to draw text. And basically, it is we're going to grab our time. Time. And what we're going to do is we're going to use a. Go back from this way. Okay, context. Append. And we want the string append. Basically, what I'm going to do is here, I'm going to type time, and then I'm going to plug in this down here. So it's going to convert it from the integer to a string for me. And then this value I'm going to plug up into here. It's going to convert from string to text. So just be mindful of this, these conversion pieces. So in Unreal there are strings, standard. There's your typical strings. There is what Unreal calls text, which is a specific version of the string, and then there is names, which is another version of a string used for like display names. So there are and this is legacy of the engine that this exists. All right. We're going to set the position here. We're going to set 30 by 30. I believe we use the tint. This is the set this to red. Oh wait, I don't want that. Just red. And font access. We'll just use Roboto. And I'm going to compile. What am I missing? Context. This is not the right node. That's painting. Here we go. Here's the one I wanted. Text color, red. There we go. This is the version I wanted. File. And we're going to go back to our first person map, and we'll go press play. It's not going to show us anything, and that's because we need to go to. There's one or two ways to do this. We can go to our world settings, and in here we can set our HUD class to be our BP HUD timer. So this would be for our level. I'm going to do it this way for right now. I'll go press play. You can see that. You can see time 10. I'm going to go back to here. I'm actually going to be scale 3. I'm going to drop this down 100. Compile. We'll go back to the third person map, and then now we can see, there we go. Not the best way to do this. All right, I'm going to tell you this right now. This is not the best way to handle. Later on, we'll use a widget to handle this. So here's our time. So we can go back to our timer. So what they're going to do next is they're going to add, not a new event graph. That's not what I want. What we want to do is add an event, add a custom event, and this is going to be count. And ultimately, what we're going to do is we're going to bring in back begin play. And we're going to set timer by event. And it's going to ask what is the event, which is going to be the count. What is the time? We'll set that to 1. So basically every second is going to count. All right, so I'm going to go back to my time variable. I'm going to set that back to 0. I thought it was counting down. It's actually counting up in this case. And what count is going to do in this case is we're going to grab our time variable. We're going to increment it. I think that's all we need to do. In the version that you see, they actually do a plus and they put a 1 down here, and then they go back and set. This is very much valid as well, and they handle it. They wire that into there instead. But I'm just gonna have you. This is perfectly fine. I'm gonna compile. We'll go back to our map and we'll go, and you can see that every second it's now. What I forgot to do, there's a checkbox for looping. I've got to turn that on. And I'll compile, go back, and press play. And there we go. Now it is counting.
Can you count faster?
I mean, that's based on the timer, how fast the timer is. But we're trying to do like 1 second count. All right. So that is basically the what we're doing. We're setting up a timer. Every second, we're attaching ourselves to that. You can set the timer to do a function instead. So there's other ways to do timers, but I'm just showing you this is the way that we're going to do the timer this week. All right, so I've shown you how possession works, how to get input. I've shown you the enhanced input system. Extra credit if you go with the enhanced input system over 1, 2, the nodes, the 1, 2, 3, 4 keys. Extra credit if you get again, I showed you. Let's go to the level blueprint. Again, I showed you how to get the pawn that was spawned in the world and how to get that, and I've used that down here so I can go back to it. So this is extra credit. These two pieces right here. Show you how to do the path runner. You are going to have questions about the path runner. Please come to me and talk to me. It is going to be the hardest part of this assignment. Again, we go back to the path runner. The big thing here is that there are these functions right here. Set the move direction, move the object, is close to target, set next target. These right here are all critical. They're all these. It makes your life Again, we go back to the event graph. Again, because once I move that piece inside here, move object, branch, select target. I mean, it's just a string of node, node, if statement, node, node. You know, begin play, node. And I'm actually going to grab this just for aesthetic purposes. Drop it up here. Put that there. See how this blueprint reads so much simpler? That's the purpose of having these functions in play. This is why we have the move object. This is why, this is this close to target? If so, then I'm going to set my next target, set the move direction, and off I go. All the independent work is going to be in these function graphs. Use these function graphs to make these nodes for you. And again, when there's a similar tactic to what you would do in C and C++ in terms of this object, to writing functions to write this as well. Those of you who are in the Unity class, you will see the path runner show up soon, really soon. So, all right. So I've shown you all pieces of the lab. Is there anything in the lecture with this that I need to go over one more time? No? Okay, I'm going to stop the recording here.